Dear students, under double integrals, the next topic of concern is change of order of integration. So what is this change of order of integration? That is, we have to integrate the given double integral by changing the order of integration in which it has been given. That is, for example, here we have a problem where we have to evaluate the double integral 0 to 1, integral 0 to x dy dx by the method of change of order of integration. So if we observe here, we have the integrals with limits where the inner integral, that is the first integral, is with respect to y and the second integral is with respect to x. This is with respect to y because the limits has x involved in it. So it is dependent on x. So whenever you have the limits which is dependent on x, the limits for the first integral will be with respect to y. And so the order of integration will be first with respect to y and then with respect to x. That is, first we have to integrate with respect to dy and then we have to integrate with respect to dx. But now here the question is, we have to change the order of integration and we have to integrate it, which means that we have to change these limits in such a manner that first we have to integrate with respect to dx and then we have to integrate with respect to dy. So in order to do that, first we have to sketch the region that is given. So what is this double integral actually? So if we rewrite it properly, that is, the first limit, as I told you, that is the outer integral is with respect to x, and so these are the limits for x. So x is equal to 0 to 1, and the inner integral is with respect to, the limits are with respect to y. So it is integral y equal to 0 to x. So this is the inner integral, and dy dx. Now we have to change the order of integration. We have to change the order of integration in such a manner that the inner integral will have limits with respect to x and the outer integral will have limits with respect to y, and hence it will be integrated first with respect to x and then with respect to y. Now in order to do so, first we need to sketch the region of integration. Now how to sketch the region of integration? For that, first we have to write these limits. So what are the limits given? That is, we will name it as old limits. So what are the old limits given? For x it is equal to 0 to x equal to 1. For y it is equal to 0 to y is equal to x. Now we shall sketch this region in the graph. So here I have drawn the x-axis. So this is the x-axis and this is the y-axis. So after drawing the axis, first we have x is equal to 0 over here. We know that this is the origin 0, 0. And where is the line x equal to 0? It is the y-axis. So at every point of y-axis, the value of x is 0 at this point. So therefore this line is x is equal to 0. Next is x is equal to 1. So we can plot the point 1 somewhere here on x-axis at certain distance. For example, I am going to plot it here. So this point I am going to name it as 1, 0. So this is of unit distance, that is 1. So what will be the line x equal to 0, x equal to 1? It will be the line parallel to y-axis at the point where we have the coordinate of x to be 1. That is, it will be, the line will be like this. So let me draw the line. So this is the line x is equal to 1. So this is the line x is equal to 1. So we are done with x equal to 0, the line x equal to 1. Next we have y equal to 0. What is this line y equal to 0? It is the x-axis, because at every point of x-axis the value of y is 1. So therefore this is the line y equal to 0. Next we have the line y equal to x. We know that it is the line which is like this. That is, for every point of x, it will be equal to y. So if you see here, x is 0, y is 0. Then at certain point, it will keep on. That is, as x increases, the y also increases with same quantity. And so the line of intersection with the x equal to 1 will be at this point. And so this is the region of integration. That is the region between the line x equal to 1, y equal to 0, x equal to y will give us the region of integration. So let us shade this region now. And so this is the region of integration. And we know that this line is x is equal to y. Okay. So now we have to find the new limits. So if you see the first old limit, outer limit is x equal to 0 and x equal to 1, which means this gives us the movement of the strip. And second is y equal to 0 to y equal to x. This will give us the length of the strip with respect to old limits. That is, with respect to the older limits, the length is parallel to y-axis. Now we have to find the new limits. Now with respect to new limits, the length of the strip will be with respect to x-axis and the movement will be with respect to y-axis. So this will change because we are changing the order of the limits. So if that changes, now to find the new limits, the strip has to be drawn parallel to x-axis. So this will be the strip. So now we have to find the movement of the strip and the length of the strip, and using that we have to find the limits for x and y. So as I told you, now the limits for y will give us the movement of the strip. So how the strip will move now? Now the strip is in this direction. So it will move like this. So if you can imagine it, so it moves in this way. So it will start from this point. So at this point, what is the value of y? Y is equal to 0. So it starts from y equal to 0 to. It moves until where? It keeps on moving like this in order to cover the complete region, and it will move until this point. So at this point we have to find the y coordinate. And how shall we find it? It is the point of intersection between the line x equal to y and x equal to 1. So how to find the point of intersection? We have x equal to y and we have x equal to 1. So the point of at the place of x, if we put 1, we will get y also to be equal to 1. So therefore the point of intersection is 1, 1. So if this point is 1, 1, what is the y coordinate over here? It is 1. So therefore it moves from y equal to 0 to y equal to 1. So therefore the movement of the strip is from y equal to 0 to y equal to 1. So this is done. Next we have to find the length of the strip. So what is the length of the strip? So this gives us the length of the strip. So what is the starting point? At the starting, it starts from the line x equal to y. So what is the value of x at this point? X is equal to y. So as the strips keeps on moving, the point changes in this line. So in general, x is equal to y is the starting point. 2. Where it ends at this line. So what is the equation of this line? For this line, the equation is x is equal to 1. So therefore, the lower limit is x equal to y and the upper limit is x is equal to 1. And this is obtained from the length of the strip. So this gives us the length of the strip. So now after finding this, we have obtained the new limits. So what is the limit of the outer integral? It will be y equal to 0 to y equal to 1. And what will be the limits of the inner integral? It will be x equal to y to x equal to 1. Therefore, the order of integration has changed from dy dx. First it was with respect to y, then with respect to x. After changing the limits, the order of integration is changed. And so first now we have to integrate with respect to dx and then we have to integrate with respect to dy. So this is how the order has changed. So let us find the integral now. So now this integral we have to evaluate after changing the order of the limits. So these limits have been changed now. So how it is changed? It is changed like this. That is, first is outer limit is with respect to y. So let us write that first. So if you see here, first we will be having integral y equal to 0. So y is equal to 0 to y equal to 1. The inner limit is this. So x is equal to y to, if you see, it is till x equal to 1. Then we have to write the given function. Here it is directly given as dy dx. So we have to write that. So it will be dx now, because we have changed the order of limits and the first limit is with respect to x, and so we have to integrate first with respect to x, then with respect to y. So let us do this now. So this integral will be equal to, the outer integral remains as it is. First we have to integrate with respect to x. So integrate with respect to dx. So integral dx is x. And this is between the limits y to 1. And then dy. So that is equal to, further, integral 0 to 1. If you apply the upper limit at the place of x, it will be 1 minus the lower limit is y. So 1 minus y dy. Now let us integrate this. So the integral of this will be, first will be integral dy, because it is 1 over here. So integral dy is y. Then this minus comes. Then integral y dy. What is the integration of y? It is y square by 2. And this is between the limits 0 to 1. So that is equal to, if you apply the upper limit, it will be 1 minus, now here if you apply 1, it is 1 square, which is 1 only. So 1 minus 1 by 2 minus the lower limit. Lower limit if you put, it becomes 0. So what is 1 minus 1 by 2? It is equal to 1 by 2. Hence the solution is 1 by 2. Therefore we have evaluated the given double integral by changing the order of integration. I hope you would have been clear with the concept of changing the order of integration. We will do more problems under this topic for your better understanding. Kindly follow the upcoming video lectures on this topic. Thank you.